Lesson number 4, the method of elimination. So we've already learned how to solve a system graphically. And we've learned one method algebraically, which is substitution. So today we're going to talk about a third method, but it's also algebraically, and that's elimination. So it says solutions to systems remain solutions if. This is kind of a biggie here, okay? Properties of equality are used to rewrite either of the equations, meaning you could multiply an equation, the entire equation, okay? The left side of the equal sign and the right side of the equal sign by something, and it still remains the same equation. It looks different. Or if you divide the whole entire equation by something, it looks different, but it's still the same equation, therefore it's going to have the same solutions. And it says the equations are added or subtracted, or any rewrite is added or subtracted. So you can do that to equations, and the solution is still going to remain the same. So exercise 1 says, consider the system shown below. Solve the system 2 ways. First, we're going to eliminate x, and then we're going to eliminate y and b. So same problem, 2 different ways. So if we want to eliminate x here, I've got to establish opposites over each other. So I need 4x. If this is 4x, I need to make this a negative 4x. So in order to do that, I'm going to multiply that whole equation by 2, which again is going to keep the solutions the same. It's just going to make the equation look different. Still, we've got that property of equality going on there, and that's all cool. So, and it says we can add or subtract these. So when I combine my terms, I've eliminated the x's. Combine the y's and get 7y is equal to 28. So now I'm down to an equation with one variable that I can solve. That's my whole purpose of the elimination, because you can't solve an equation with 2 variables in it. So you've got to eliminate one of them somehow. So we have chosen to do this, like I said, by elimination. So now we've got the y, so we've got to find the x that goes with it. So I'm going to take that y, and I think I might plug that in to my first equation. Doesn't matter which equation, you're still going to get the same thing. 4x plus 20 equals 12. 4x equals negative 8. And we end up with x is negative 2. So my solution to this system is my coordinate negative 2, 4. And if I graphed those 2 equations, they would intersect at that point. So part B, it says eliminate y. So in order to eliminate the y's, I'm going to multiply this bottom equation by negative 5, because if I have 5 up here, I need a negative 5y down here. So we leave the first one alone. But we change this bottom one, and again, it's still equivalent, it just looks a little different. And that's negative 40. So when I combine, the y's are eliminated. So 14x equals negative 28, and x equals negative 2. Awesome. So good so far. Okay. So now I have my x. So see what happens when you eliminate the y's. You solve for the x first, and now I've got to find the y that goes with that. So I don't know. I'm going to plug it into the second equation. Again, it does not matter. So 4 plus y equals 8, and y is equal to 4. So again, there's my solution, negative 2, comma 4. It says, show that the point that you found in A and in B is a solution to the system of equations. So how do we show that something is a solution? That's our check to see if we get true in both equations. So when I take my negative 2, 4, and always go back to the originals, 4 times negative 2 plus 5 times 4, I'm subbing into the first equation. So that's negative 8 plus 20, that's true, 12 equals 12. And now I'm subbing into the second equation. Plus 4, does that equal 8? 4 plus 4, that certainly does equal 8. A true and a true makes this true. That is the solution. Okay. So looking at exercise 2, it says solve the following system of equations by elimination and check that your answer is a solution. So solving this by elimination, and it's not telling us which one to eliminate. So it's your choice. So I think, I don't know, I'm going to eliminate the y's just because I already have a negative and a positive here. So, but how am I going to get opposites over each other? So just multiply these two in your head. What's 2 times 7? It's 14. So I'm going to get a negative 14 over a positive 14. So how am I going to do that? I'm going to multiply this one by 7, and I'm going to multiply this one by negative 2. Watch the magic. Okay, and again, it's okay to multiply one equation by something and another equation by something else. I'm just changing the way they look. They are still equivalent. Make sure you multiply everything by that 7, and then in the bottom, everything by that negative 2. And what's that, negative 86? Now, whoops, did I make a mistake? Negative, that should be, there's my mistake. I need to multiply that by a positive. So positive and becomes positive and positive. All right, now I'm working here. All right, so my y's eliminate, and I end up with 39x equals 156? Yeah, and x should equal, is that 4? I believe so. So I've got the x, now I've got to find the y. So take that x and plug it back into either one of the originals. Again, it doesn't matter. I think I might plug it into the second one just because I want to. Plus 7y equals 43. 8 plus 7y equals 40. Whoops. Equals, where'd my cursor go? 43. 7y equals, if I subtract 8, I end up with 35, and y is equal to 5. So my solution is 4, 5. For the sake of time, I'm not going to do the check on this, but we know how to check that solution. So when we flip the page, I would love, love, love if you did exercise 4 and come into class with it done. We're going to do exercise, oh, we have 2 exercise 4s. I want you to do that exercise 4. This exercise 4, we're going to do together in class. Or, I lied again. So we're going to do this one right now. So it says 2 numbers have the following properties. So let's read through this. The sum of the larger and twice the smaller is equal to 13. Okay? So I'm going to start and I'm going to say, I'm going to call the larger one x and the smaller one y. Okay. Then it says twice their positive difference is equal to 8. So I've got my 2 equations that I've just underlined. It says, what are the 2 numbers? So my first one, the sum of the larger and twice the smaller. So x plus 2y is equal to 13. There's my first one. Then my second equation, twice their positive difference is equal to 8. Twice their positive difference. So positive difference would have to be in large minus small is equal to 8. So I'm going to have you finish that one up. Okay? So I would do some distributing and then see if you can solve for x and y for that one. Okay? So I started you on that one, so go ahead and finish up on that one to come to class. Go ahead and flip it. Let's take a look at lesson 4. So exercise 1 is going to be our warm-up in class. All right, so you don't have to do this one now. That's going to be our warm-up. Okay. So if you flip that over, let's do exercise 2, and then we'll be done. Okay. So it says there are many different problems that can be modeled with linear systems. The modeling just means we're writing our own equations. So let's try one where we use information given to determine unit prices. So it says Samantha went to a concession stand and bought 3 pretzels and 4 sodas and paid $11.25. Raza went to the same stand and bought 5 pretzels and 2 sodas and paid $8.25. And then it asks, could pretzels have cost $1.75 each and sodas $1.50? How can you evaluate based on the information given? So what I would go through and I'd say, okay, let's look at Samantha's equation. So 3 pretzels. So 3 at $1.75 plus she bought 4 sodas at $1.50 and it said she spent $11.25. Is that statement true? Okay. Go ahead, do that calculation and see if you get that to be true. Well, then let's see about Raza. So it says Raza's equation would be 5 pretzels, so 5 at $1.75, plus 2 sodas at $1.50, and it says she spent $8.25. Is that one true? Okay, so you should come up with that this first one is true, but this second one is false. So they both went to the same concession stand. Could pretzels be $1.75 and sodas be $1.50? No. Okay, can't happen. So now it says, let X equal the unit cost of a pretzel. So X is pretzels and Y are sodas. So Roz's equation would be 3x plus 4y equals what she spent. Samantha's equation. And then Roz's equation would be 5x plus 2y equals 8.25. Solve the following system using elimination. So it doesn't say whether you should eliminate the pretzels or the soda or the X's or the Y's. So it's, again, your choice. Okay. So I'm going to get you started on this one, and then I'm going to have you finish it to come to class. So when I look at 3x over 5x and I look at 4y over 2y, I think I might eliminate the y's because I can easily multiply this second equation by -2 because that will eliminate the y's for me in one step. So I'm going to leave that first equation alone. And then I'm going to multiply through the second equation, -10x minus 4y equals -1650. Now, those y's eliminate, so I'm going to let you go from there. So you're going to find x first, which is the cost of the pretzels. Then you're going to have to use that to find the cost of the sodas. And then I want you to answer D. So you're going to finish this, and you're going to do that one. Okay? All right, we'll see you in class.